Hello everyone, and welcome back to another video from the LM Math Circle. Today we're going to be talking about probability, which is sort of somewhat along the lines of what we did last week with the counting, but probability is definitely a whole nother big idea of mathematics, and it's actually one of the most useful parts of mathematics, for real life applications. So we're just going to start with the basics of probability so that we make sure that everyone understands what we're doing. So some of you may have seen or know how to do some of this stuff, but we want to make sure that everyone understands what we're doing. So we're going to start off with what is the definition of probability? We probably heard the word, but what does it look like in math? So probability, we can write like a fraction. So a fraction, we've all seen it. We have the line. The top part above the line is the numerator. Below the line is the denominator. So in the top of our fraction, we would write total, and we can say successful outcomes. And I'm going to explain what that means. That says outcomes. Sorry for the terrible handwriting. And the bottom says total possible outcomes. So it'll be a lot clearer when we do an example. So we have two dice. So we all know dice. Let me see if I can draw. We have a dice. And they're labeled with the dots, usually like 1, 2, 3, 4, 5, and up to 6. So there's 6 sides, and let's say we have 2 of them. So we're going to roll 2 dice. What is the probability that the sum of the numbers rolled is 2? So I'll say it again. What is the probability that if we roll 2 dice, the sum of the numbers, so let's say we roll a dice and we get a 3, and on another one we get a 2. Well, the sum of that is 5, but what is the probability that we roll and we get a 2? So we're going to use our formula. So first, let's figure out how many total possible outcomes there are. So to do this, let's draw what can we get from the first dice? Well, we know we can get a 1, 2, 3, 4, 5, or 6 when we roll it. Same thing for the second dice. 1, 2, 3, 4, 5, 6. So let's say that we roll a 1 on the first dice. What are the possibilities that we can get in terms of the sum? Well, we can get 2, because if we roll a 1 with the second dice, we can get 3, we can get 4, and so on. So you see that if we roll a 1 with dice number 1, there's 6 outcomes, because there's 6 possibilities that are all different with the second dice. So you'll see that if we roll a 2, there's 6 new outcomes. And if we roll a 3 with the first dice, there's 6 new outcomes. So how many total do we have? Well, we have 6, because if we roll a 1 with the first dice, there's 6 total outcomes, plus 6. If we roll a 2 with the first dice, plus 6, plus 6, plus 6. So we actually have 36 outcomes total. Or a faster way to do that would have just been 6 times 6, because we have 6 numbers on the first dice, 6 numbers on the second dice. So we have 6 times 6 total possibilities. So our fraction bar, 36, is going to be on the bottom. There's 36 different sums that we can get. We could get a 4 on the first dice and a 5 on the second. That's one possible. That's one out of these 36 possibilities. But we want to know how many of those 36, in how many of those 36 will the sum be a 2? Well, we know that the only way to get a 2, a sum of 2, is 1 plus 1, meaning we need to roll a 1 on both dice. And that's the only way. So there's only one successful outcome. Successful meaning what we want. We're looking for a 2 as the sum of the two numbers that we rolled. So that would be the only successful outcome. There's only one, which would mean the answer is 1 over 36, the fraction. So let's do another example. This time we're going to look at same setup. So we have 2 dice. We roll both of them. What is the probability that the sum of the numbers rolled is 4? So it's a similar problem. And so therefore we know that the denominator, or the total possible outcomes, is still 36. There's still 36 different ways we can roll 2 dice. So now we just need to figure out the numerator, which is, well, how many ways can we get the sum of the numbers to be 4? Well, how many different ways are there to get to 4 by adding? We know if we roll a 1 with the first dice, we need a 3 in the second dice. If we roll a 2 with the first dice, we need a 2 with the second dice. If we roll a 3 with the first dice, we need a 1 with the second dice. We can't roll a 4 with either because it would have to be 0, but we don't have a 0 on our dice. So that means there's 3 possibilities. So it's 3 over 36. We can simplify this fraction, meaning we can reduce it to simpler terms, because 36 divided by 3 is 12. So that just simplifies the fraction, but 3 over 36 is still correct. In math, we just like to write the simplest form of a fraction, or reduce it, we say. So that would be 1 over 12 would be the answer. So that's a very simple probability question, but it's super important that we sort of understand that, because that is the fundamentals for all probability questions. So now let's look at probably a more sort of complicated problem. It says that a box contains 5 cards. So let's draw the 5 cards. So we have card 1, and it will have a 1 on it. Card 2 has a 2 on it. Card 3 has a 3 on it. Card 4, and card 5. So it says we have these 5 cards numbered 1 through 5, and 3 cards of the 5 are selected randomly without replacement from the box. What is the probability that 4 is the largest value selected? So let's go through that one more time. There's 3 cards selected randomly without replacement. So without replacement means, let's say that we choose a 1 as our first card. That means that when we select our second card, we can only choose from these 4 because the 1 has already been taken. That means that's what without replacement means. So the question, though, is what is the probability that 4 is the largest value selected? Well, what can we do first? Take a moment to try this problem, and then if you have no luck, you can skip forward, and I will give the solution. Okay, so I hope you tried the problem. It might be a little bit difficult. So like I said in the beginning of the video, probability is actually connected to what we did a couple weeks ago or last week with counting, and combinatorics, combinations, stuff like that. So we're going to use that here in this problem. So first, we're going to draw our fraction, because the probability, like we have written up there, is total successful outcomes divided by total possible outcomes. So we're going to find the denominator first, which I recommend you do in most problems, because it sort of helps you sort of see what you're trying to solve. For the top part, if you know all the possible outcomes, you can then narrow it down to the successful outcomes. So total possible outcomes. we're actually going to use combinatorics. We're going to say we have 5 cards, and we're going to choose 3 of them. So we can write that as combinatorics. So some of you might remember the formula. I hope you remember it. For these big parentheses, or what we would call 5 choose 3, it will be 5 factorial over 3 factorial, times 5 minus 3 factorial. And again, to state why we got 5 choose 3 is because we have 5 total cards, and we're selecting 3 of them. So 5 choose 3, and that's the combinations of how many ways you can choose 3 from 5. So we can simplify this. We get 5 times 4, and then this 3 factorial will cancel with the rest. So I can draw that out quickly just to show what I mean. We would have 3 times 2 times 1, but it's going to cancel out with the 3 factorial right here. And then we still have the 2 factorial from the 5 minus 3 factorial. So that will equal 10. So that's our total number of possible outcomes. We need to find total number of successful now for the numerator. So it says, what is the probability that 4 is the largest value? So to do this, let's write out our 5 cards up here. 1, 2, 3, 4, 5. And it says that 4 is the largest value, which means we can actually cross out 5, because if we chose a 5, that would mean that 4 isn't the largest value. We can also circle 4, meaning we know we have chosen 4. That leaves us with these 3 numbers. So the question actually boils down to how many ways can we choose 2 of these 3 numbers? Because remember, we're choosing 3 cards total, but we already chose a 4, because it says what's the probability that 4 is the largest of the 3 cards. So we already chose that. We now need 2 more cards from this set of 3 right here. So again, we're going to use combinatorics, and it's going to be 3 choose 2. Using the same formula, it's 3 factorial over 2 factorial over 3 minus 2 factorial equals, and you can simplify that, and you'll get 6 on the top divided by 2 on the bottom, which equals 3. So the answer is 3 over 10, because 3 is the total number of successful outcomes, 10 is the total number, and we can't simplify 3 over 10, so that is our final answer. So we're going to do one last problem in today's video, and the problem says that we have a deck of 4 red cards labeled A, B, C, and D. We also have a deck of 4 blue cards, again labeled A, B, C, and D. So total, we have 8 cards, 2 separate decks though. One is blue, one is red. The question is, what is the probability of drawing a winning pair? A winning pair is when 2 cards are the same color or 2 cards are the same letter. So what is the probability of drawing essentially 2 cards of the same color or 2 cards of the same letter? Well, let's use our formula for probability. We first are going to find the total possible outcomes. However, we're actually going to do it in a sort of clever way. We're not going to find all the total number of outcomes. We're going to select one card. So let's say that we choose this red D. This is the first card that we chose. Well, how many other cards now can we choose? 7, right? So 7 is what we're going to put in the denominator. Now, how many successful outcomes are there? Of these 7 remaining cards, which of them will result in the outcome that we want? Meaning, which of them will give us 2 cards of the same color or 2 cards of the same letter? Well, there's only one card that gives us the same letter, so that's one outcome. But there's 3 cards that give us 2 cards of the same color, so that equals 4. So the answer is actually just 4/7. So that's sort of a simple way to sort of look at this problem, because there's a bunch of different possibilities. You could have a red A and a blue C. That's a possible outcome. But we only looked at possible outcomes if you choose a red D. Like, that's how we got 7 as our denominator. Because if you choose a red D, there's only 7 possible outcomes for the other card. But like I said, there's a whole other bunch of possibilities if you don't have a D. Like I said, there's the red A and the blue C. There's the red B and the blue A. That's the total possible outcomes if you're not just looking at a red D being selected as the first card. But we did look at the red D, and the reason was it simplified the problem entirely. It made it just 7 possible outcomes. We easily found that 4 of them work, and it's 4/7. But you might be wondering, well, aren't you ignoring all of the other cases? Like, what if you choose a red A as your first card? It's still 4/7. There's still 7 other possibilities if you choose a red A for your second card. I mean, like, if you choose a red A as your first card, there's still 7 possibilities for your second card. And there's still 4 possibilities for successful outcomes. We can choose a red A and a blue A, or we can choose a red A and a red B, a red A and a red C, or a red A and a red D. So it's sort of symmetry. It's for every letter that we choose first, whether it's red or blue, A, B, C, or D, it's always going to be 4/7, which means the total probability is just going to remain 4/7 because of symmetry. So that's one sort of trick that you can use to simplify probability, is what we just did in this problem. We looked at one specific case and realized it's symmetrical for all other cases, meaning if we choose a red D first, it's the same for all other 7 letters. So it's 4/7 no matter what letter you choose first. And thus, the probability, or the answer to our question, is 4/7. So I hope you learned something from this video about probability. It's definitely an introduction to probability, because probability gets super crazy and complicated the higher and higher you go up in the math fields and the more complicated math you start to do. But it's super important that we understand the beginning of it, because you can't get to the hard stuff if you don't start with the foundation to it. So I hope that it makes sense and you learn something. And good luck in the problem set. And like I always say, if you have any questions, you can email us or attend the Zoom meeting where we'll be answering questions about probability, about the problem set, or any other just random questions that you have about mathematics. So thank you for watching and enjoy your week. Oops.